Hey everybody, so in today's lesson I'm just going to go through the Chapter 7 review. So for the first one, we have the triangle proportionality theorem. Since we have these lines that are parallel to each other, we can set up the proportion. I usually like to do it by extending this parallel line and then just putting an equal sign. And that's actually the proportion we're going to use. 6 over x equals 4 over 2. So you might have set it up a different way. You might have done 6 over 4 equals x over 2. You might have done 2 over 4 equals x over 6. You might have done x over 6 equals 2 over 4. Either way, as long as you're matching up the corresponding parts, you'll get the same answer. But if you do something like setting up by saying 6 over 2 equals 4 over x, that doesn't work because 6 doesn't correspond with 2. So you can't do it that way. Either way, you should get the same answer as me. 6 times 2 is 12. X times 4 is 4x, so we get 4x equals 12. And then divide by 4, and you get x equals 3. Number 2, we're basically just filling in the missing blank. So we have 7 over 2 equals a over b. So we can move this around a little bit, and instead say, how about numerator over numerator equals denominator over denominator? So that would be 7 over a equals 2 over b. So the question mark there would be 2. For the next one, we have 9 over n equals 4 over m equals 18 over n equals what over m. So if you notice, the n and the m stay as the numerators, but the denominator, they stay as the denominators. But 9 turned into 18. So what did we do to 9 to get 18? We doubled it. So if we do 9 times 2 to get 18, we have to do 4 times 2, and that would give us 8. Okay, number 3, which of the following is false? We'll just write true and false on all the lines here. So the first one, we have 15 over x equals 17 over y. And then we have y over 17. So what did we do? How did we get y over 17? Well, we took the second ratio here, and we just flipped the numerator and denominator. So 17 over y became y over 17. So if we flip this numerator and denominator, we have to flip this numerator and denominator. So that would become x over 15. So since they both just flipped, that one's true. But if we only flipped one of them, that would not be true. So in B, we have 5 over 8 equals x over 12, but then the other one is 12 over x, which is flipping the x and the 12, but then we didn't flip the 5 with the 8, we kept it the same. So if we're going to flip x over 12, we also have to flip the 5 and the 8. So this should say 8 over 5. Since it doesn't, that's false. And then for C, 5 over x equals y over 3. So then we have x over 5, so that would be flipping the 5 and the x. So then we would have to flip the y and the 3, which we did, 3 over y. So that one's true. Okay, so that's how proportions work. If you're going to flip one side, you have to flip the other. Okay, the next page, we're going to find the length of AE. So AE is this entire length. So if we can figure out what AC is, then we can just add 12 plus whatever AC is to get the length of AE. So they give us the proportion that we're going to use, AB over BD, so we just plug in the numbers. AB over BD, that would be 3 over 9, equals AC over CE. AC we don't know, so we can either write X over CD or CE, or we can actually just write, I'm just going to write AC, just so in the end I know exactly what I just found. So I'm going to put AC over CE, which is 12, and then just cross multiply. AC times 9 would be 9AC. 3 times 12 is 36. And then to solve for AC, I divide both sides by 9, and we end up getting AC is 4. Okay, so since we get that AC is 4, we can figure out now what the length of AE is. 12 plus 4, that's 16. So the length of AE is 16. Number 5, the two trapezoids are similar. What's the value of x and the value of y? So right when we see the word similar, we know that similar figures have congruent angles and proportional sides. So for angles, we set up an equation. For sides, we set up a proportion. So let's start with the angles. So we have 3x. That corresponds with 70. Corresponding angles are equal, so I'm going to say 3x equals 70. So then to solve that equation, I'm just going to divide by 3. So when I do 70 divided by 3, I get 23.3 repeating. Or you can write it as 23 1/3. Okay, the next one is finding y. So with the sides are proportional. So we have to match up. What does 4y correspond with? 4y corresponds with 12. So I'm going to write it as a ratio, not an equation. So 4y over 12 equals, and then my other ratio would be comparing the other side from this trapezoid to the corresponding side of this one. So that would be 6, which corresponds with 9. I didn't mention this in the previous one, but I've mentioned it in other videos. We can reduce fractions if we see them. So 6 over 9 can reduce by dividing the top and bottom by 3. So that would reduce to 2/3. You would end up getting the same answer with the reduced numbers as you would without reducing them. If you're using a calculator, reducing doesn't much matter. But if you're looking to just do some mental math, you might want to reduce. So like here, 6 over 9 reduces to 2/3. 4 over 12, that reduces to 1/3. Just imagine how easy the numbers would be then. Once you have 1 over 3 equals 2 over 3, the numbers would be so much easier to multiply. I'm going to do it the long way, but if you reduce them, you will get the same answer. So 4y times 9, that's going to give us 36y. 12 times 6, that's going to give us 72. And then divide both sides by 36, and you get y equals 2. So however you do it, you should get y is 2. The answer will never change, but the proportion could change depending on your liking. All right, number 6. The heptagons are similar to each other. So which of the following statements of proportionality is not true? So if the heptagons are similar, we have to write a proportion that would match corresponding parts. So BC over NO, BC corresponds with NO, that's true, and then ED corresponds with QP. So this one's true. They want to know which one's not true. All right, next one, RQ with FE. Let's see if that works. RQ goes with FE. Yep, that's true. And then OP over CD, that's also true. So everything matches. The next one, RM with EF. So RM, EF. No, that's not true. RM goes from the 3 arc marks up to the top left. EF goes from the bottom left to the 3 arc marks. So this one here, that's not true. They don't match up. And then CD with OP, even though CD matches with OP, RM doesn't match with EF. Okay, and then the next one, MN over AB, that matches. PQ with DE, that's true. And then the next one, BC, matches with NO, that's true. And then FA matches with RM, so that's also true. So the only one that was not true was C. All right, number 7, simplify. So we have 3 feet over 20 inches. Since they're 2 different units, we want to convert them to the same unit. So what we can do is convert feet to inches by multiplying the number of feet times 12, because there's 12 inches in 1 foot. So if there's 3 feet, it's going to be 12 inches, 12 inches, 12 inches, 3 times. So that would become 36 inches over 20 inches. And now that they're in the same unit, we just reduce the numbers. 36 over 12, or 36 over 20, that reduces. We can divide them both by 4. So if we divide 36 by 4, we get 9 inches. And if we do 20 divided by 4, we get 5 inches. So that would reduce to 9 over 5. All right, on to the next page, number 8. Find the scale factor. So scale factor means we're just going to find corresponding sides and compare them. So they want the scale factor of EFGH to ABCD. So EFGH, that would mean we're going to start with this one and then relate the corresponding side with the other one. So the only side they give us these two. So the 4 would correspond with AB. Since we don't know what AB is, we're not going to use the 4. The 10 would correspond with the 6. So since we know what both of these numbers are, that's the ratio we're going to use for our scale factor. So since we're doing EFGH to ABCD, we're going to do 10 over 6. And 10 over 6 reduces. You always want to reduce your scale factor to the smallest fraction. So they're both divisible by 2. So 10 divided by 2 is 5. 6 divided by 2 is 3. So the scale factor is 5 to 3. Number 9, the triangles are similar. Which of the following is not true? So let's see. First one, angle K is congruent to angle F. Let's look. Angle K has one arc mark, angle F has one arc mark. That is true. The next one, FEG, so that goes from one arc mark to two arc marks to no arc marks, is similar to KLM, one arc mark to two arc marks to no arc marks. That matches perfectly, so that's true. The next one, GE over ML, that works, equals GF over MK. That's also true. The next one, ML over FG, I found it. ML does not correspond with FG. It goes from no arc marks to 2. FG goes from one arc mark to none. They don't match. They're not corresponding, so this one's not true. And then the next one, angle M is congruent to angle G. By the third angle theorem, if these two angles are congruent to these two angles, then the third angle theorem says that angle M is congruent to angle G. So that one's also true. Okay, number 10. Find the value of x and y. So let's start with x. So I'm going to circle x. X corresponds with 15. So I'm going to write x over 15 equals, and now I need another ratio. So x was the left side of the small triangle. What's the other sides of the small triangle? Well, we don't know this one, so I can't use that. But we do actually know this one because the whole length is 9. This piece is 6, so 9 minus 6 leaves us with 3. So that's what I'm going to use for my next ratio. So since I did the left side of the small over the left side of the big, now I'm going to do the bottom of the small over the bottom of the big. So that would be 3 over 9. So be careful with that. Make sure you're matching up corresponding parts. Left side of small over left side of the big, bottom of the small over bottom of the big, which is the whole number. We can reduce 3 over 9 to 1/3, or just cross multiply, and you get 9x equals 45, and then divide by 9, and you get x is 5. Okay, to find y, y is the top of the small, so we can do y over y plus 8, but we don't need to because if you take a look at this one, we have parallel lines. So we can just use the triangle proportionality theorem. So we can do y over 8 equals 3 over 6. So anytime you have the parallel line here, you can do the triangle proportionality theorem. So that green is kind of hard to see. Okay, we're going to cross multiply now, or we can reduce first. So 3 over 6 reduces to 1/2. So we can do that if you like, or we can do 8 and 6, that reduces to 4 over 3, however you want to do it. So I'm not going to reduce, I'm just going to multiply. 4 times, or y times 6 would be 6y. 8 times 3 is 24, so 6y is 24, and then divide by 6, and we get y is 4. So if you reduce, you should also get y is 4. Okay, next one, number 11. We're just solving the proportion for number 11. So cross multiply, we can do 5 times y is 5y. 25 times 15, that gives us 375. And then divide 375 by 5, and we get y equals 75. Okay, the next one, we're going to cross multiply. The 4 multiplies with the x plus 1. I'm going to put the x plus 1 in parentheses because it's a quantity. And then the 2 multiplies with the 6, or with the 3 and gets 6. Distribute the 4 in, so we get 4x plus 4 equals 6. Subtract the 4, we get 4x equals 2. And then divide by 4, and we get x equals 0.5 or 1/2. So either way would be fine. Okay, number 12. Trying to solve for y. So for this one, y is the top of the big triangle. 12 is the top of the small triangle. So we're going to do y corresponds with 12. And now we need to think. We did the side of the big over the side of the small. So the other big side would be this whole side. which is 8 plus 12, which is 20. So it'll be 20 over the left side of the small, which is 8. So that's a tricky one to see, but we did. Top of the big over top of the small equals left side of the big over left side of the small. So that's how our proportions need to work. We need to match up corresponding parts. We can reduce 20 over 8 or 12 over 8, however you want to do it, or you can just multiply. 8 times y is 8y. 12 times 20 is 240. And then you're going to do 240 divided by 8, and you get y is equal to 30. Okay, number 13. We have these parallel sides. So we can use our triangle proportionality theorem. That would be 20 over x equals 40 over x plus 4. Cross multiply, or we can reduce 20 over 40. That reduces to 1 over 2. That would be so much nicer to use 1 and 2 instead. But if you want to just use the big numbers, go ahead. 40 times x would be 40x. 20 times x plus 4, you can write it as 20 parentheses x plus 4, or just distribute right away. 20 times x is 20x. 20 times 4 is 80. To solve this one, subtract 20x from both sides. We get 20x equals 80, and then divide by 20, and you get x is 4. Okay, for number 14, that's the angle bisector theorem. So the way that one worked was this side is being divided up into 8 and x, so I'm going to put x over 8. So since I did the left over the right, I'm going to do the left over the right. That would be x plus 6 over 20. We can reduce 8 and 20, that reduces, or we can just multiply straight through. 20 times x is 20x. 8 times x plus 6 would be 8x plus 48. Subtract the 8x from both sides, we get 12x equals 48, and then divide by 12, and you get x is 4. Okay, next page. Now we have our similar trapezoids. So a lot of questions being asked here, so just one at a time. So we're going to do the scale factor of ABCD to EFGH. So that would be the left one to the right one. So for scale factor, you need to compare two corresponding numbers. So if we look at all the corresponding sides, we have x over 6, z over 12, 3.5 over y, and then 4 over 8. Only one of those ratios involves two numbers. So we have to choose the one that involves the two numbers, and that would be 4 and 8. So for the scale factor of ABCD to EFGH, that would be 4 over 8. And 4 over 8, as we know, reduces to 1/2. The scale factor of EFGH to ABCD, that would be 8 over 4. And 8 over 4 reduces to 2 over 1, or just 2. Okay, now we're going to find x, y, and z. So to find x, let's see, what does x correspond with? So x corresponds with 6, so I'm going to write x over 6 equals, and now I need to do another ratio. So I did 1 from the left side over 1 from the right side, so now I'm going to do 4 over 8. I have to do 4 over 8. I can't do x over 6 equals z over 12 because we don't know what z is. And I can't do x over 6 equals 3.5 over y because we don't know what y is. So you always have to just find one variable at a time. So make sure that your proportions only have one missing variable. Otherwise, you won't be able to solve it. Cross multiply, we can reduce first and then cross multiply. Either way, I'm going to get 8x equals 24, and then you get that x is equal to 3. So I'll put a 3 there since we have it now. All right, the next one I want to find y. So let's see, y corresponds with 3.5. So I'm going to do y over 3.5 equals, so now since I did the right side over the left side, I need to do the right side over the left side again. So I'm going to do y over 3.5 equals 8 over 4. I can't do 4 over 8, so since I started with the right over the left, I have to do right over left again. Cross multiply, and you get 4y equals 28, and then divide by 4, and you get y is 7. Okay, the last one. Now I need to find z. So z corresponds with 12. I'm going to do z over 12. And I did the one from the left over the one from the right, so I'm going to do 4 over 8. Cross multiply, you get 8z equals 48. And then divide by 8, and you get z equals 6. All right, so now we have all the sides. So now they're asking us for the perimeters. So the perimeter of ABCD, I'm just going to add these sides together, and you should end up getting, let's see, 3 plus 4 is 7, 7 plus 6 is 13, 13 plus 3.5 is 16.5. So the perimeter of ABCD is 16.5. The perimeter of the other one, 6 plus 8 plus 7 plus 12, that would be 33. And now they want the simplified ratio comparing the two polygons. So now we're going to do 16.5 over 33. If you divide that in your calculator, you get 0.5, which is the same as 1/2. So 16.5 over 33 reduces to 1 over 2. Now notice from the beginning, the ratio of the sides was 1 to 2. The ratio of the perimeters should also be 1 to 2. So if you don't get the same ratio, then you might have made a mistake. Okay, the next one, number 16 through 19, we're going to say, are they similar or not? And if so, by what postulate or theorem? So for the first one, number 16, we have two right triangles. The only thing we know about them is that they each have one right angle. But just because we have two right triangles doesn't mean that they're similar. Any two right triangles aren't necessarily similar to each other. You could have a 30, 60, 90. You could have a 45, 45, 90. Just because they have one right angle doesn't make them similar. So that's not enough information. So these are not similar. Number 17, they give us all the side lengths. They don't give us any angles. So if all the sides are proportional, then they're similar by SSS. But we do need to always check that. You can't just assume because they give you 3 side lengths, then it's going to be similar. You have to set up your ratios. So let's pick any side you see here. I'm going to start with 12. 12 is the smallest side of JKL. The smallest side of GHI is 36. So that means that they're corresponding. So I'm going to write them as a ratio. 12 over 36. All right, the next pair of corresponding sides, after 12 comes 15, and then after 36 comes 45. So 15 corresponds with 45. And then our last corresponding pair, that would be 25 over 75. Now, to determine if they're proportional, we just have to reduce all those fractions. So 12 over 36, that reduces to 1/3 or 0.3. 15 divided by 45 is 0.3. And 25 divided by 75 is 0.3. So since they all reduce to the same decimal or fraction, that means that they're similar or proportional. So these are similar by SSS. Okay, number 18, we have, looks like BE is perpendicular to AD. So if this is 90 degrees, then the angle to the left of that is also 90 degrees. So in this triangle, we have one arc mark and a 90. In the other triangle, we have one arc mark and a 90. Since we have two pairs of congruent angles, these are similar by angle. All right, and then the last one, they only give us two sides in each triangle. So we can't use SSS. They don't give us any angles, but we do know the vertical angles are equal. But that's not enough to use angle. But since we have two sides with an angle between them, and then two sides with an angle between them, we might be able to use SAS as long as the sides are proportional. So we're going to match up the corresponding sides. So 2 is the small side in this triangle, 4 is the small side in this triangle. So 2 corresponds with 4, and that means that 3 corresponds with 6. 2 over 4 reduces to 1/2. 3 over 6 also reduces to 1/2, so that means the sides are proportional. So these are similar by SAS. Okay, now the next one, number 20. We're just filling in the missing part. So we're just matching corresponding parts here. So we're doing xy over yz. So that would be between the top two parallel lines and then the bottom two parallel lines is equal to BC, which is the top two parallel lines, and then that would correspond with CD, which is the bottom two parallel lines. So actually what you're looking at is this blank here should correspond with the one that's next to it. So YZ corresponds with CD. So that's our answer. Same thing in the next one. AX over XY equals AB over what? So XY corresponds with what? So XY corresponds with BC. The next one, what over BC equals XZ over XY? Well, XY corresponds with BC, so XZ corresponds with BD. And then the last one, AD over what equals AC over XZ? Again, XZ corresponds with BD, so D is also BD. All right, and then we're going to finish it up with just a few more similar triangles. So here, this one, we have the parallel lines, so we're going to use our triangle proportionality theorem. So that would be 8 over 12 equals 12 over x. Cross multiply, we get 8x equals 144, and then divide by 8, and you get x is 18. For number 22, it's going to be x over 12 equals 5 over 10. Cross multiply, you get 10x equals 60. And then divide, and you get x is 6. And then the last one, this is the angle bisector theorem. So we're going to do x over 8 equals x plus 6 over 20. We can reduce 8 and 20, or we can just multiply. We get 20x equals 8x plus 48. Subtract 8x, we get 12x equals 48. And then divide by 12, and you get x is 4. All right, so that's our Chapter 7 review. If you do have any questions, make sure you let us know. Have a good day.